Pre-APCalculus. This is Notes 9.1. We're going to be looking at some trigonometry, and we're going to start out with special right triangles. Hopefully you'll recall this from geometry. The first is the 45, 45, 90. That's a right isosceles triangle. In every 45, 45, 90, the two legs have to be the same length, which I'm going to call from here on out SL for short leg. The hypotenuse is always the same length as the short leg times the square root of 2. Let's look at an example. Here's how I suggest you do this, but ultimately, as long as you get the correct answer, the work doesn't matter to me. First of all, we know this is an isosceles right triangle because it shows that both these lengths are x. According to the isosceles triangle theorem, these angles have to be the same. And if you cut the 90 that we have left in half, there's 90 left because there's 90 here. These two together are 90. Cut them in half equally because the isosceles triangle theorem, those are each 45. So 45, 45, 90. Label each leg short leg. Label the hypotenuse short leg square root of 2. Now, if we take this equation and solve it for the short leg, we would divide both sides by the square root of 2. Rationalize your denominator by multiplying this by 1 in the form of square root of 2 over square root of 2. That's going to give us the short leg is 8 square roots of 2 over 2, which reduces to 4 square roots of 2. X, in each case, is the short leg. So we are saying that x is 4 square roots of 2. If you need to see more examples of that, there are some links on my website to my geometry notes that you could see more examples. This is a review, so I'm just going over one example. Hopefully you remember how to do this. All that being said, this concept here of these two special right triangles is going to be used in lots of problems for lots of months in this class. 30, 60, 90. Always call opposite the 30 the short leg. Opposite 90 is always double the short leg. Opposite 60 is always the short leg times the square root of 3. So I'm suggesting when you get to your picture, label opposite 30 the short leg. Label opposite 90 double the short leg. Label opposite 60 the short leg times the square root of 3. Now, the short leg times the square root of 3 is the only equation that we have in which it's equal to a number. So I'm going to divide both sides by the square root of 3, trying to get the short leg by itself because that's our variable. Rationalize the denominator by multiplying it by 1 in the form of square root of 3 over square root of 3. That's going to give us 9 square roots of 3 divided by 3. Both the 9 and 3 are outside of the radical, so we can divide those both by 3 and get the short leg is 3 square roots of 3. So to figure out what y and r are, y is going to be 3 square roots of 3. R is going to be 2 times 3 square roots of 3. 2 times 3 is 6, so it's 6 square roots of 3. Just to make sure this is clear, I'm saying y is 3 square roots of 3 and r is 6 square roots of 3. Makes sense because opposite 30, if that's 3 square roots of 3, opposite 90 is supposed to be double that. Double 3 square roots of 3 is 6 square roots of 3. That concludes the first of, I think, 5 videos, 6 videos for this, maybe 7 videos for this section. Review of special right triangles.